Now, there are two problems with this way of comparing structures. The first problem is that if somewhere else in this program we need to compare two other movie objects, we have to repeat this big fat if statement. So as we have more comparisons, our code is going to get longer, and over time it's going to become harder to maintain. The second problem, which is hidden, is that if tomorrow we decide to go back to the movie structure and introduce a new member like director, then we have to remember to go back and modify all these if statements and include a new condition for comparing the director. There must be a better way. This is where member functions come to the rescue. So a structure can have variables for storing data, but it can also include functions. Now here we can define a function for comparing a movie object with another. Now with this, we're essentially going to move this big fat logic inside a single place, inside the movie structure. So we're not going to repeat it all over the place. And also, if tomorrow we decide to change this logic, there is a single place we need to modify. Let's see how this works. So back to the movie structure. We don't need the director member. Let's define a function that returns a Boolean. We're going to call this equals and give it a parameter of type movie. So all the logic for comparing two movie objects is going to end up here. So now I'm going to grab this if statement, copy it and paste it here. Now here we need to make a few changes. So we don't have an object called movie1. What we want to do here is comparing the members of the current object, like title, release date, and so on, with the members of another object. So anywhere we have movie1, we want to replace that with nothing. So I'm going to select all these instances and delete them. Okay. Now for movie2, anywhere we have movie2, we're going to replace that with movie, the parameter of this function, like this. Okay. So if all these conditions are true, then we're going to return true. Otherwise, we're going to return false. Now, this is a very poor way of writing code like this. This is not how a professional software engineer writes code. So there's a way to simplify this. We can get rid of all this noise and add the return keyword right here. So if all these conditions are true, the result of this expression is true. So we're going to return true. But if one of the conditions is false, the result of the entire expression is false. So we're going to return false. We don't need an if-else statement here. Okay. Now let's add a semicolon and reformat the code to make it easier to read. So I'm going to put the title on a new line like this. Good. So now we have a single place where we have the logic for comparing movie objects. If tomorrow we decide to add a new member like director, this is the only place we need to modify. So we simply add a new condition to compare the director. Okay. Now back to the main function. We're going to get rid of this fat if statement. And instead, we're going to say, if movie1 that equals movie2, then print equal. As simple as that. Our code is shorter, cleaner, and easier to maintain. There is just a tiny problem. With our current implementation, when we call this function, this movie object is going to be copied in memory and eventually get stored in this parameter. We can improve this by using a reference parameter. So now the movie object is not going to be copied across. Instead, we're going to get a reference to this movie object in memory. Okay. There is just one more problem. With this implementation, we can go in this function and change any of the members of this movie object. So we can change the title of this movie. Why is this a problem? Well, if you're calling this function to see if two movie objects are equal, we don't want this function to sneakily update this other movie object. Okay. So to prevent this from happening, we make this a constant parameter. Now we cannot write code like this. Good. Now, one last thing before we finish this lesson. So here we have defined a function. Now, more accurately, going forward, we're going to refer to these functions as methods. So a method is a function that is part of an object, which can be an instance of a structure or a class. Again, we're going to talk about classes in the next part. But what I want to point out here is that here we have a movie object, movie1. And when we talk about the equals function, it's more accurate to call this the equals method. So one more time, A method is a function that is part of an object.